In this video class, I'm going to attempt to do both the top and bottom flap of section 2 of your Unit 11 flipbook titled Quadratic Relations. Here is the top flap. First thing, essential question. What is a circle? What is a circle? And here is the math definition of a circle. A circle is the set of all points which are the same distance from a given point called the center. So if we looked at this, let's go ahead and label this in our graph. Let's go ahead and pick a point. I'm going to pick a point right here at 2, 1, and I'm going to say that is the center. That's the center of our circle. And let's go ahead and label the coordinates. It's going to be at 2, -1. Alright, and then it says it's the set of all points which are the same distance from the given point. That means if we have a particular radius, then that radius is going to be the same all the way around. Everywhere around this point we're going to be the same distance away. I'm going to go ahead and draw, or try to draw, a circle here and see if I can get it to be the right size. I'm not sure if this drawing tool is going to work, so let's give it a try. I need to get it to be 4 units. Let's see, there's 4 units. 1, 2, 3, 4. It's a little bit big. I'll try a little smaller than that. Alright, let's see if I can get that to work. Alright, so that looks pretty good. So I'm going to sketch a circle. You can stay with me a second, class, because once we show you how radius affects a circle, you can sketch this circle pretty easily. Alright, so what we're looking at here is that this particular circle is going to have points that are the same distance from the center. Let's go ahead and draw a line from the center straight up. Oops, the wrong drawing tool. Let's draw a line straight up from the center. Oh goodness, I'm still got the wrong drawing tool. Let's try one more time. So there is a radius that's straight up from the center. I'm going to change the size of that so it's a little bit smaller. Okay, let's go ahead and label that. So we'll draw an arrow to this, and let's call this the radius. The radius is this distance. It's the same distance. It's this distance from the center. So the radius here, if you look at it, is 1, 2, 3, 4. So our radius here is 4 units. And if you draw a radius every direction, class, what's nice about it is it's pretty easy to do that, to use that to sketch a circle. If I drew another radius right here, straight from the center, and then go to the right or to the left, and then I go down and draw another radius this way, I can get that to be as straight as I can. That's good enough. And I draw another radius this way. If you do that on a graph, then what's nice is it usually is fairly simple to go ahead and sketch the circle. All you have to do is connect these 4 points together with a somewhat of a curve, and you'll end up being able to sketch the circle. It won't be perfect like it is on the drawing, but you'll be able to get a reasonably good circle. So there's our definition of a circle. Now, take a look at this right side. Circle equations. If you remember, class, a parabola, or a quadratic equation which makes a parabola, the equation of a parabola, has one squared term. It is the x squared. But in a circle equation, circle equations have x squared and y squared. They have both x squared and y squared. Now the general form of a circle looks like this. It gets kind of messy. I'll give you an example of a general form equation for a circle. X squared plus 6x plus y squared. I'll just put plus 14y equals 9. And you can see we've got an x squared, a squared x term, and a squared y term. And this is actually going to form a circle. If we plug in x's and y's, you'll actually get a circle with this equation. Now the problem with the general form is it does not tell us center or radius. So really, it's hard to get information from this general form. It will make a circle, there's no doubt about that. But we can't look at this form and know where is the circle or how big is it. But there's another form we're going to learn about, and it's called standard form. And it's going to look somewhat familiar to you. I'm going to write it in just variables. X minus h squared plus y minus k squared equals r squared. Now you should see some similarities here between a vertex form quadratic. You've seen x minus h squared in a vertex form quadratic. And the cool part about this form for a circle is this. The h value and the k value tell us the center. So the center is at h comma k. But here's something tricky. Notice that the k is now minus k. In vertex form quadratic, it's plus k. It's minus k, just like minus h. That means you got to remember something very important. For a standard form circle equation, you flip both signs. So you flip the sign on h to take it out of the equation, and you flip the sign of k. So the center is at hk, and you might have already figured this out. This little small r actually stands for something. The radius of our circle, let me write that a little bit better. The radius of our circle is r. So from the standard form, you get center at hk and radius at r. General form, you really can't find out anything about the circle, where it is or what size it is. So we want to be able to get everything we can in standard form so we can actually know something about the circle. All right, and we're going to move on. I got about 7 minutes to go. Let's go to the bottom flap here. And here's our essential question for the bottom flap of section 2. How do I derive the equation of a circle using the distance formula? So write that essential question and then continue the video. If the center of a circle is labeled as HK, so let's go ahead and do this. Let's label the center of our circle as H comma K. Okay? And a point on the circle is labeled XY. Let's go up here and pick a point on the circle, and we'll label this as XY. Then we can use the Pythagorean theorem to find the equation of every circle. So let's see if we can do this. Now we know, class, we're going to draw I'm going to draw a line segment between these 2 points. Let's do that right now. Wrong size. Let's see if I can do that. Okay, so there's a line segment right there. That actually is the radius, by the way. And I'm going to turn this into a right triangle. And the reason why is because, hey, we're trying to derive the equation of a circle using Pythagorean theorem. That means we got to have a right triangle somewhere. So we're going to make a right triangle right here. And let's go ahead and label this angle as a right angle. So we've got a right triangle here. And I'm going to label this leg. Let's label this leg A, and this leg B, and then this leg, our hypotenuse, we're going to label as C. Okay, now we know that A squared plus B squared equals C squared. That's the Pythagorean theorem, and that's a right triangle, so that must be true. Well, if you look at our equation, if you look at our 2 points, HK and XY, I can tell you right now that if I want to describe the length of A, I can do that like this. I can say the length of A. If you look at this point right here, class, this point is actually X, because we're traveling X units to the right. It shows you this right here. And it's actually, the other part of this is K. The reason why is because K is our Y value. K describes where we are on the Y axis. x describes where we are on the x-axis. So this point right here, this corner, is actually xk. If that's the case, that means the length of side A is actually x. There's our x value of this point minus h. So the distance between this point of our right triangle and this point is x minus h. This value right here, b, this can actually be described as, well, think about where this point is right now. We've got the y value of this point is actually y, and the y value of this point right here is k. So that means if we took y minus k, that's going to tell us how long this leg is. So this leg is described as x minus h, the x value of this point minus the x value of this point, and leg b is described, the length of leg b is described as the y value of this point minus the y value of this point, which is y minus k. So if you substitute, oh, and one more thing, we could also say that the hypotenuse is actually the radius. So let's call it radius, and we'll just call that variable, the radius, is small r. All we have to do now, class, is substitute. So if a squared plus b squared, I'm going to move this over, if a squared plus b squared equals c squared, then we know that a is x minus h. So I can substitute x minus h for a. B is the same as y minus k. I can substitute that for b. And c is just the radius. So I can make that the radius. Now do you see right here where what we did? We actually, by drawing this circle and playing with the properties of a right triangle, labeling a couple points with hk and xy, we can actually use the Pythagorean theorem to show that this is actually, this is just the standard form of a circle. And it's actually of every circle. And you notice from this standard form now that hk happens to be the center. And r is the radius. So right below here, let's just go ahead and label that. The center, just like we had in our answer over here, the center is going to be found at h comma k, and the radius is known by the value of r. So this is how we can actually derive the standard form of a circle using the distance formula. And that is the end of section 2.